Good morning. My name is Kane Bassett, and I'll be conducting a sensitivity analysis for capital budgeting briefing. The introduction to sensitivity analysis is um, identifying some techniques that can be used in capital budgeting to determine how different variables or independent variables affect a particular dependent variable. Some of the key steps involved in the sensitivity analysis are quantifier analysis through scenario planning to assess feasibility under different realities, and quantitative analysis using techniques such as sensitivity coefficients, the tornado diagram, and the Monte Carlo simulation, um, to numerical measurements that impact the net present value, which is referred to as NPVs. Uh, the quantitative steps are in sensitivity analysis are first identifying some key inputs of variables that could potentially change over the life of the project. Um, this may include, some of the project services input, potential regulations, and other factors. The next is developing a different scenario to depict alternate realities based on the different combinations of some of those key variables. After that, we have feasibility and attractiveness of the project that can be assessed under those different scenarios. Um, Others are the determining some of the plausibility of these upper and lower variables that could be reasonably expected for each of the variables. And other techniques like sensitivity coefficients, tornado diagrams, and the Monte Carlo simulation can also be used for a deeper quantitative analysis. This will provide measurable insights into exactly how much each variable impacts the NPVs, excuse me. Uh, Identifying these key variables, uh, the focus should be on inputs that are most likely to change and that have a greater potential to impact on the NPVs. We have to identify these variables that are most influential and allow close monitoring and controlling of the most significant factors that will affect the NPVs. Um, Most of those will enable productivity and mitigating project risk. For example, key variables often include project demands, units sold, sale prices, fixed and variable costs, raw material costs, operating expenses, taxes, and interest rates. Uh, Scenario planning and sensitivity coefficients. Um, they both are developing alternative versions of the future by changing some of those key variables. Scenario planning will test the robustness of the project across a range of possibilities instead of relying on just one uh, base forecast. And the sensitivity coefficients measures the proponent changes in the NPVs for a given change in an input variable. Common scenarios are best case using optimistic values, worst case using pessimistic values, and the most likely cases using expected values. Scenario planning imports important benefits such as preparing for the different realities and unanticipated outcomes that may measure over the life of the project. The sensitivity of the coefficient uh, qualifies the responsiveness of the NPVs to change in each input, allowing comparison of the impact of those variables. The tornado diagram. The horizontal bars represent the spread between the highest and the lowest of the NPVs generated by the upper and lower values for each variable. This tornado is like a diagram visually depicted which variables have the greatest impact on the NPVs. It serves as an analytical aid to identify the most influential variables and demonstrates the range of possible NPV outcomes under different scenarios. Incorporating project risk as two main methods in risk into the capital budget. One is the discounted rate for account for the project risk level. The other method is the Monte Carlo simulation to generate numerous scenarios that variable all randomly based on defining the possibilities of the distribution for each variable. It calculates a range of possible NPV outcomes and likelihoods of each. But in summary, the sensitivity analysis evaluates the impact on a project's NPVs of changing key input variables. This helps assess feasibility under different scenarios and supports the risk of analysis for better decision making. Both quantitative scenario planning and quantitative methods such as sensitivity coefficient, tornado diagrams, and Monte Carlo simulation provide insight and applying sensitivity analysis, which leads to more informed capital budgeting decisions. If you have any questions, please let me know. Thank you.